Welcome to the Explainer. So, when you hear the word textiles, I'm guessing your mind probably jumps straight to clothing, right? Well, today we're going to completely shadow that misconception. We are diving deep into the incredible world of textile technology. And trust me, this isn't just about fashion. This is a high-tech, advanced engineering field that's literally solving some of the most massive global challenges we face today. From engineering advanced materials to leading the charge in sustainable manufacturing, this explainer is your absolute ultimate blueprint to becoming a professional textile technologist. Let's get into it.
Think about this for a second. What do artificial hearts, spaceship fuselages, and sustainable fashion actually have in common? The answer: advanced textiles. We really need to debunk this myth that a textile degree just means working with t-shirts. No way. Textile technologists are the brilliant minds engineering biocompatible artificial organs. They're the ones weaving carbon fiber composites for aerospace applications and deep space exploration. And they're the pioneers driving green chemistry to clean up global manufacturing. You aren't just making clothes here. You are literally engineering the future.
And that's exactly where the industry is heading. Take a look at these sectors. In MediTech, engineers are creating implantable devices like hernia meshes and synthetic surgical sutures. Then you've got mobile tech, where they're providing the lighter, stronger structural composites needed for the booming electric vehicle market and aerospace. Plus, we're seeing huge growth in smart wearables. Think integrating IoT sensors right into the fabric to monitor your health in real time. And of course, eco-friendly manufacturing is building these incredible closed-loop circular systems. These massive global sectors are driving absolute sky-high demand for skilled technologists who can engineer these advanced materials.
So consider this explainer your ultimate cheat sheet. Today, we're going to cover the academic roadmap, branch comparisons, labs and internships, student success strategies, and finally, global careers and salaries.
Let's kick things off with Section 1, the academic roadmap.
Getting your B.Tech in Textile Technology is a rigorous, highly respected STEM path. To even get your foot in the door, your admission relies heavily on a really strong foundation in 12th standard math, physics, and chemistry. You're also going to be looking at competitive entrance exams depending on your region, things like JEE Main, JEE Advanced, WBJE, or TNEA. You're stepping into a true engineering discipline, and the entry requirements absolutely reflect that high standard.
Now, what does this actually look like over 4 years? Well, your first year tackles foundational engineering and basic sciences. But year 2 is where you dive straight into polymer chemistry and the mechanics of pre-spinning. Year 3 gets incredibly complex. We're talking chemical processing, advanced dyeing, and knitting mechanics. And finally, in year 4, you master technical textiles and total quality management. That's where you gain the essential quality control skills that industries rely on to make absolutely sure their materials never fail.
If you look closely here, you'll notice how the core subjects focus heavily on material characterization and process dynamics. But the electives, that's where you carve out your niche. You can choose to study nanotechnology or specialize entirely in medical textiles, where you're learning about cell biology and biomedical engineering alongside fabric construction. These electives are amazing because they allow you to tailor your degree directly to the specific global sectors driving tomorrow's innovation. Moving right along to Section 2, choosing your path, branch comparisons.
It is absolutely crucial to understand the difference between textile technology and textile engineering. Think of it kind of like this. Textile engineers build the machines. They use heavy thermodynamics and statics to design systems based on performance requirements. Textile technologists, on the other hand, are highly applied. If you choose technology, your focus is deeply on the materials themselves, how fabric architectures behave, polymer physics, and applied manufacturing. You are learning how the structures actually work on a much deeper level, from the raw fiber all the way to the finished functional product.
Now for the fun stuff. Section 3, hands-on labs and industrial internships. Programs in this field feature some seriously state-of-the-industry fabrication facilities. You might literally find a full-scale manufacturing plant just sitting in a campus basement. Your daily responsibilities will shift to rigorous material testing. You'll be evaluating single-fiber strength under electron microscopes and mastering industrial spinning. You'll analyze exactly how yarn is formed from polymer to product. It's not just textbook learning. You are out there operating the exact same testing and production equipment used in global manufacturing to ensure quality control. But as cool as the labs are, they aren't quite enough. You've got to transition into the industry. First up, target composite mills for your 4 to 8 weeks of industrial training. These are the places doing spinning, weaving, and dyeing all under one roof. Second, treat it like an investigation. Maintain detailed technical logbooks of machinery specs and chemical concentrations. Third, actually talk to the machinery operators. Seriously, they know all the real-world troubleshooting you won't find in any textbook. And finally, master those digital CAD and simulation tools. This practical experience is the exact bridge you need to launch your professional career.
Which brings us to Section 4, Strategies for Student Success.
Okay, I absolutely love this. This is a brilliant study hack shared by senior engineering students called the hands-on garment analysis. And you can literally do this right now with the shirt on your back. Step 1, analyze the construction. Is it woven or knit? Step 2, identify the exact materials. Are we talking natural fibers or synthetic blends? Step 3, map the mechanical and chemical processes it went through, like dyeing or water-resistant coatings. And Step 4, suggest improvements for any structural faults. Making this a habit constantly connects the abstract classroom theory to the physical, real-world products right in front of you.
I just had to include this quote from Dr. Russell Gorga because it perfectly captures the journey. He says, "They come in August as students and they leave in May as professionals. It's hard work." And you know what? It really is. By your senior year, you're designing antimicrobial textiles, optimizing manufacturing processes, and sometimes even patenting products with government agencies before you've even walked across the graduation stage. It's a massive, rigorous transformation.
And finally, the part you've probably been waiting for. Section 5, Global Careers and Salaries.
Let's look at the incredible opportunities in India first. Because these roles require really specialized, cross-disciplinary skills like material science and IoT integration, they pay significantly more than traditional textile jobs. As a technical textile product developer, you're looking at 6 to 12 lakhs per annum. Medical textile engineers pull in 6 to 11 LPA, and smart textile systems engineers can see up to 13 LPA. You're being well compensated for high-level, critical engineering work in sectors that have an absolute zero tolerance for failure.
And the overseas earning potential? It is massive. $79,100. That's the upper average for senior R&D and product development roles in the United States at major athletic and medical brands. But it's not just the US. There is huge demand for process engineers in Malaysia's cleanroom fabrications, production managers in Vietnam's high-performance garment hubs, and sales executives across the GCC region. Your degree is quite literally a global passport.
The sheer diversity of the industry's hiring technologists right now is staggering. You are definitely not boxed into one corner. You can work in defense, creating ballistic protection, in healthcare, designing wound care fabrics, in sustainable fashion, driving eco-friendly supply chains, or in smart electronics, weaving conductive wearables. Every single one of these sectors desperately needs professionals who understand the complex physics of flexible polymers and fibrous structures.
So, as we wrap up, I want to leave you with this one provocative question. Which global challenge will your textile solve tomorrow? Whether you want to clean up the environment, innovate life-saving medical devices, or engineer the next generation of space travel, a B.Tech in Textile Technology gives you the exact tools to do it. It's a fascinating, deeply impactful path. I really hope this explainer has sparked your curiosity and given you a clear roadmap. Keep learning, stay curious, and I'll catch you next time.